Let's take a look at the questions on homework number 2. We'll start with combining like terms. When you combine like terms, you're looking to add or subtract depending on the sign that's in front of each term, but only with terms that either both share the same variable or both have no variable at all. So you'll notice here when I circle in red that both of those items contain the variable c. So I'm going to ignore that letter for now. I'm going to compute the math for these two numbers. So 2.2 and 3.9. I'm going to add those together. I can either do it mentally or I can do it on a calculator. If you don't have your own handheld calculator, you can open the Desmos calculator down here on the bottom left. So here is my input screen, and I'm going to type 2.2 plus 3.9. And when I click enter, the value will pop up over here all the way on the right hand side. 6.1. So I know that my answer is going to have a 6.1 with a C. Now I have to combine any other terms that are also alike, such as these two, because they both contain no variable at all. Notice when I boxed them in blue that I also boxed the signs that's in front of them. So the first one is a minus 4.7, and the last one is a minus 6.9. Now when the minus sign is in front of your first number, it's like a negative sign. And when the minus is in front of the second number, that's the actual operation. Here on this Desmos calculator, they don't have a dedicated negative button. But on your calculator, you might have one down here in the lower left corner. I guess the lower right corner of your calculator, lower left of my screen. That's a negative sign. That's a subtraction sign. And they look different on this TI calculator. But when I use the Desmos calculator, it's just one single button. So I'm going to clear out my old math there. Whoops. And I'm going to type this time negative 4.7 and then subtract 6.9. And over here's my answer. It's negative 11.6. So I know the first one was 6.1 with a C, and then minus or negative 11.6. Choose the correct response and submit. Alright, let's take a look at this question here. The width of a rectangle measures 2.4x plus 3.5 centimeters, and its length measures 1.2x plus 6.8. Which expression represents the perimeter in centimeters of the rectangle? So let's draw a quick picture of what we got here. So for a rectangle, we're actually going to have a width of 2.4x plus 3.5 on both sides. And then along the lengths, we're going to have a 1.2x plus 6.8. Again, on both sides. So since the perimeter is all the way around, we're going to have 2 of each length. And we could write this out the long way, where we would write 2.4x plus 1.2x plus 2.4x plus 1.2x. We could certainly write all of that. Or we could just say we have 2.4x plus 3.5s plus 1.2x plus 6.8s, and just double both of the lengths and the widths at the beginning. It's up to you if you feel comfortable with distributing, or whether you just want to add all 4 items together. So 2 times 2.4 is going to be 4.8 with an x, and 2 times 3.5 is going to be 7. And over here I've got 2 times 1.2, which will be 2.4 with an x, and 2 times 6.8, which will be 13.6. Now instead of adding 4 numbers together, I can just add these 2 if I'd like. Again, you can do it mentally or you can use a calculator, but we're going to add 4.8 and 2.4. And we're going to get 7.2. And then we're going to add our constants. We're going to get 20.6. So we're looking for a 7.2 with an x and a 20.6 with no variable. 7.2 with an x and 20.6 with no variable. So that would be this response here. I think you're starting to get the hang of it, so let's take a look at the second topic. Distributing a negative. So anytime you have a negative or looks like a subtraction sign outside of a parentheses, there's actually a 1 in front of it. And that's the number that you are going to distribute. And a negative 1 is going to multiply by each of those terms inside the parentheses here. This is going to remain the same. But inside the parentheses, all of the signs are going to change because timesing by 1 doesn't do anything. So all of the numbers will remain the same, all of the variables will remain the same, but all of the signs will change. So this will become a minus 3w, and that will become a minus 9. All right, let's type that in here. Remember the first term stayed the same, 0.4v, but then we got a minus 3w and a minus 9 because all of the signs inside will change. Let's try another one. So this minus sign is going to disappear because I'm going to distribute it to each item inside the parentheses. And when I distribute it, both the parentheses will disappear, the minus sign out here will disappear, and all of the terms inside the parentheses will change signs. So my answer here will be positive 3y and then minus 3.4. So everything in here will change signs. One last time. This will change signs from a negative 0.1p to a positive 0.1p, and this plus 4 will become a minus 4. Think you're getting the hang of it? Let's try the next topic. Sign numbers on a number line. Point S is located at negative 4, and it's shown on the graph. Points T and U are 10 units away from point S. So they want you to plot point T and point U on the number line below. So you can count the units if you need to. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can call this, click on the graph to plot a point, and then if you want to move it, you just click it again to delete it. So we're going to call this T. It's located at negative 14. And now we need to plot U, which is going to be 10 units in the other direction, or 10 units to the right. So if I go from S to 0, right, negative 4 to 0 is 4 units. So I'm going to need 6 more to get to 10. So that's how I'm going to plot this second point, by trying and using that number line as my math. So let's try one more problem. Point G is located at negative 13. Point H is 3 less than G. So that's lower or farther away from 0. So 3 units to the left will be less. So once I've moved 3 units to the left, I can mark that as negative 16. I think you're starting to get the hang of this. So I'm going to move on to the next topic, which does have a drop-down menu on it once you plot these values. They want you to plot negative 9.5. So I go to negative 9, and then I go halfway to negative 10. They also want me to plot negative 7.5. So I'm going to go to negative 7, and then go halfway. And up will pop the actual questions. They want to know if negative 9.5 is greater than or less than negative 7.5. Well, anything that's closer to 0 is bigger. So negative 9.5 is further to the left, so that makes it less than. Negative 9.5 is less than negative 7.5 because it is further to the left. Let's plot two more. Negative 5.5, negative 9.5, and now they're asking you about negative 5.5. Negative 5.5 is greater than negative 9.5 because it's further to the right. Let's try adding and subtracting some integers without using our calculator. So here's the rule when adding or subtracting integers. It must be an addition problem. That means there must be an addition sign in between these two numbers in order for us to combine them together. And once we create an addition problem here, then we can follow the addition or combining rules. The rules are simple. It must be an addition sentence, and if the signs of the two numbers are the same, you add the digits together. If the signs of the two numbers are different, you subtract. You take the sign of the larger number, and then you'll be exact. So we had 5 minus 12. In order to create an addition problem, we must change this operation to add the opposite number. So that minus sign is going to turn into an addition sign, and that 12 is going to turn into a minus 12. So now I can look at my two values because this means to combine. So 5 is positive, 12 is negative. They have different signs, so we subtract. We put the larger number in our head first, 12. We take away 5, 7, and then we take the sign of the larger number, which is negative 12. Now when we choose which is the larger number, we simply choose by looking at the digits and not the signs of the numbers. So 12 is larger than 5, so our answer is negative 7. You could certainly use a calculator for this, but you wouldn't get much good mental math practice. So try doing this on your own. Again, every sentence has to be an addition sentence. So what you're going to want to do is you're going to want to change that subtraction to adding the opposite number. So instead of 8 minus 12, we're going to keep the 8, we're going to change this to addition, and we're going to change that to negative 12. These two numbers have different signs. Different signs, subtract. 12 minus 8 is 4. Take the sign of the larger number, negative 4 it is. Okay. Again, every sentence must be an addition sentence. If we don't have an addition sign between our values, we add the opposite number. So I'm going to keep the first one the same. Keep this, change this to addition, and change this to the opposite sign. So technically now I have negative 4 plus positive 8. Again, the signs are different, so I'll subtract. 8 minus 4 is 4. Take the sign of the larger number, my answer is positive 4. Let's try the next topic of multiplying or dividing fractions. When you multiply fractions, you multiply numerator times numerator. And then you multiply denominator times denominator. So 3 times 7 is 21, and 8 times 8 is 64. (21/64) will be my answer. You can type it as a fraction by using your keyboard backslash button, or you can open this virtual keyboard and you can type a fraction by pressing the division key. Whoops, it should be 21 division 64. Now, when you are dividing fractions, you have to change it to a multiplication problem. all division symbols have to be changed to multiplication. But once you do that, you also have to follow by taking the reciprocal of the second fraction. You keep the first one the same, you change it to multiplication, and you flip the second fraction over. That's called the reciprocal. Now we're back to the same rules as before. Multiply the numerators, multiply the denominators. Now you'll notice at the front here at the beginning, these two diagonal numbers have a common factor. So I could have reduced it before I multiplied, or I'm forced to reduce my fraction at the end, which is dividing them by that same common factor. So although 4/6 is correct, it's not a simplified fraction. So I'm going to reduce it by dividing both by 2 and getting 2/3, which will be my final answer. If at the beginning, when I had kept my first fraction the same and multiplied by the reciprocal, if I had wanted to, I could have divided these by 2 at the beginning and then multiplied. And when I do my reducing at the beginning, oftentimes I deal with smaller numbers, and I don't have to do it at the end. So our answer here is 2/3. Multiplication, there's no flipping, no reciprocals. You simply do numerator times numerator, denominator times denominator. If you do your multiplication first, you're going to get some really big numbers that you're going to have to reduce later. If you try and do your reducing at the beginning, then instead of multiplying 1 times 5 and 5 times 3 here, instead of doing that, I'm going to divide these by their common factor of 5. So 5 divided by 5 is 1. So this one and this one will both become 1s. 1 times 1 and 1 times 3, and there's our final answer. The last topic is converting between mixed numbers and improper fractions. When you convert a mixed number, you multiply the denominator, that's this number here, times the unit. You multiply the denominator times the unit. Once you get that value, you will take that number and you will add it to the numerator. 5 times 8 is 40. 40 plus 1 is 41. The denominator never changes. So 41 fifths. First you multiply the denominator times the unit, and then you add the numerator. 41 fifths. Oops. This next question is asking you to go in reverse. They want you to convert 99 tenths into a mixed number. So first you have to divide 99 by 10. If you're using a calculator, you're going to get a decimal answer. 99 divided by 10 is 9.9. But what they really want to know is what's the unit. And the answer here is 9. 10 can go into 99 9 times. Because 10 times 9 is 90. But I need to get to 99. So that means 99 minus what I already have will be my remainder. This number here is my remainder. The remainder goes in the numerator, and the denominator never changes. So if it was 10 at the beginning, it will be a 10 at the end. So 9 and 9 tenths is our mixed number. Okay, one more time. Try dividing 40 by 9. If you don't know your times tables, you can use a calculator. 40 divided by 9 is 4. So 9 times 4 is how much we have so far, or 36. We have 36. So I know that my unit is 4. And I know that gave me 36. but how much do I have left? Well, 40 minus 36 will tell me how much I have left. That's called a remainder. So remainder is 4. My denominator never changes. 4 and 4/9. That's it.